Hello everyone, welcome to elespectrum. Have you ever wondered how complex power systems are simplified into a single, easy to understand diagram? If yes, then you have come to the right place. Welcome to this session on the basics of single line diagram or SLD, the universal language of electrical engineers. In this video, we will explore what is an SLD, why it's essential, what are the basic elements of SLD, and how to prepare basic SLD. So, what is single line diagram? A single line diagram is a simplified representation of three-phase power system using a single line. Now, the question is why we are representing this three-phase system into a single line. So, first thing is here we are considering a balanced steady-state condition of the power system. When the system is in steady-state mode, the voltage and current of all the three phases are balanced and the values are almost the same. Only difference is the phase shift between the three phases. Hence, we can consider the representation of three phase into a single line. Another thing is that, as we know, the power system is huge, starting from the generation to the transmission to distribution and to the consumption. And now to represent this complicated system, the single line is very helpful for electrical engineers for planning, designing, and operation of the power systems. Moreover, it also helps in understanding the electrical path from generation to the consumption for the various networks. So, if this is clear to you, then let's discuss what are the different elements of a single line diagram. First is a bus bar. A bus bar is a kind of a junction point in any substation. It serves the purpose of distributing electrical power to multiple circuits in the substation. There could be multiple feeders connected to this bus bar, for example, incoming transmission line, outgoing transmission line, a transformer feeder, a capacitor bank feeder, right? A bus bar is represented as a straight line, as you can see here in the symbol. Next element is a circuit breaker. Circuit breaker is used to switch a feeder while a load is connected. It is also used to disconnect a feeder during faulty condition or any abnormal condition. It is similar like a switch what we are using in household to switch a fan or a light, but it is different in terms of technology and construction as it is used to switch high voltage or high power circuits. A circuit breaker is represented like a switch, as you can see here in the symbol. Next element is a disconnector or an isolator. It is used to switch a feeder while load is not connected. It is very important to note here that when a load is connected, we cannot use isolator for switching the circuit as it does not have the capability for it. The construction of an isolator is such that you can visually see if a circuit is connected or disconnected. This is very important in terms of safety when we want to do the maintenance of a feeder. The isolator is represented like a circuit breaker but slight differently as you can see here in the symbol. Next element is an earthing switch. An earthing switch is used to connect the circuit with ground. It is used to get rid of the trapped charges which is highly required for the safety during maintenance. An earthing switch is represented like a switch, but one part is connected to the ground and one part is connected to the circuit as it can be seen in the symbol. Next element is a current transformer. A current transformer is used to step down the current of the feeder. So the primary side of the current transformer is rated for the line feeder current, and the secondary side of the current transformer is generally 1 ampere or 5 ampere. So basically it is stepping down hundreds of ampere of current to 1 ampere or 5 ampere, which then can be fed to a protection relay or measuring device for the protection or measurement of the feeders. It is represented as shown here in the symbol. Next element is a potential transformer or a voltage transformer. It's similar like CT, but it is stepping down the voltage, high voltage to low voltage for the measurement or protection purposes. It is represented as shown here in the symbol. And the next and final element is surge resistor. A surge resistor is used for the protection of a circuit or its components from surges by diverting it to the ground. It is placed in front of the circuit or element which is to be protected. It is represented as shown here in the symbol. So these are the basic elements right now we are going to discuss. Of course, there are more elements which are used in a single line diagram, but these are sufficient at the moment to discuss how to prepare a single line diagram. Now let's focus on our main topic, which is how to prepare a basic single line diagram. We will go step by step by adding each element to the single line diagram, and we will also understand logically how these components are placed in the single line diagram. So let's prepare a single line diagram for a feeder. As you can see here, this black line is a feeder, and this feeder could be a transmission line, a distribution line, or a feeder connected to transformer or a capacitor bank or any other requirement in the substation. And this feeder is connected to bus bar in the substation. Now this bus bar, as you can see here, is represented as a thick line, and we also need to mention the rating of this bus bar. Here we have mentioned the rated voltage, rated current, and rated short circuit current of the bus bar. So let's see how this bus bar looks like in a substation. As you see here, this part is a bus bar in a substation. You can see that multiple feeders are connected to the same bus bar, and it is acting as a junction point for the substation. Let's see another example. Here, this is bus bar of a switchgear system. You can see there are three phases R, Y, and T, three bus bars, and from this each bus bar or each phase, there are different tapes are taken for different feeders. So this is also an example of a bus bar. Now, as the feeder is connected to bus bar, we need a switching device to switch on and switch off the feeder, which is circuit breaker in this case. As you can see, 52 CB circuit breaker is placed in between bus bar and feeder to switch on and switch off the feeder. We are also mentioning the rated parameters of circuit breaker here, which are the rated voltage, rated current, rated short circuit current, and type of the circuit breaker. Generally, for the high voltage and medium voltage systems, we are using SF6 type or vacuum type circuit breakers. Let's see some example photos from site for the circuit breaker. Here, this is a single pole type circuit breaker where for each phase we have one pole, as you can see here. This is one pole for one phase, second for another, and third for the third phase. Here, this what you see here is interruption chamber for the circuit breaker. So the interruption chamber is inside this insulation part, which is used to switch on and switch off the system. Let's see another photo. This is another type of circuit breaker. Here, as you can see here, this is the part where the line is connected. This is in terminal. Here is the interruption chamber, and this is the out terminal for one phase. Similarly, we also have for second phase and or also for the third phase. As we can see, one terminal of circuit breaker is connected to one part of circuit, and another terminal of the circuit breaker is connected to another part of the circuit. And so this is a series element in a circuit. Now, as we discussed that the interruption chamber of circuit breaker is inside this enclosure, Hence, we cannot visually check if a circuit breaker is on or off. And for this, we need one another element to add in the single line diagram, which is disconnector or an isolator. Now, as you can see here, we have added two isolators, 89A and 89L, in the circuit. This 89A is required to isolate the circuit breaker from busbar, and this 89L is required to isolate the circuit breaker from the line side. Generally, in a substation, you have digital signals for disconnector and also for circuit breaker to check if the circuit breaker or disconnector is in open or closed position. But when you want to do the maintenance of system and enter into the switch yard, it is necessary to have the visual disconnection of circuit, and that's why this disconnectors are important. And also, if you want to do the maintenance of a circuit breaker, it is necessary that it is isolated from any of the potential source. And that's why, suppose if you want to do the maintenance on this side, we need to have a disconnector on this side so that circuit breaker is free from potential of this bus bar. And similarly, we have a disconnector on line side so that we don't have any potential from line side when we are doing the maintenance on this side of the circuit breaker. Let's see some photos of disconnector, how this look like. So this is one example. Here, as you can see, this is a single break type of disconnector. That means we have a fixed point here, and this is the moving part. And this is also represented here in single line diagram also. You see, this is the fixed part, and this is the moving part which gets connected. And it is necessary that we also show here in single line diagram in a proper manner, and we also need to do the connection of this disconnector itself in similar way. Here, this fixed part should be towards circuit breaker and moving part towards bus bar. And here also the fixed part should be towards circuit breaker and moving part should be towards the feeder side. Let's see another photo of disconnector. Here this is different type of disconnector where we have double break type of disconnection. That means here as you can see we have this three insulators, and this is one part of the circuit, this is another part of the circuit, and at the center we have this moving part. So altogether both the connection are disconnected or connected. As you can see, similar like circuit breaker, disconnector is also a series element in the circuit. Also, there are many different type of disconnectors that we are using in substation. That depends on the type of layout arrangement and type of bus bar scheme what we are using. And regarding this, we will discuss in another video. So next element which is important for the single line diagram is an earthing switch. As we discussed, earthing switch is required to discharge the trapped charges to the ground. So for that, we are placing two earthing switch on each side of the circuit breaker, as you can see here, to safely do the maintenance on both the side of circuit breaker. And we are also placing one earthing switch towards line side so that if we want to do the maintenance on line side, we can do that safely. As you can see, this earthing switch is connected, one part is connected to the circuit and another part is connected to ground. So this is a shunt element of the circuit. Let's see some photos of earthing switch from substation. As you can see here, this is a photo of earthing switch for one phase. As you can see, this is the continuous line of the circuit, and in front of that we have connected this earthing switch. So this is the moving part of earthing switch, which is the moving blade, and this is rotated with the help of this shaft. So when this blade is connected to this live part, then the circuit is considered as off, and when this blade is rotated and it is open, the circuit will be on off. Let's see another example of earthing switch. So yeah, this is an example of combined disconnector earthing switch where we also have the part of disconnector or isolator. We also have the part of earthing switch combined D in a single device. So generally, whenever there is possibility to have a combined part, we are using it in substation. For example, here in this case, we can have a combined disconnector earthing switch. Here also we can have a combined disconnector and two earthing switches for the line side. Now let's discuss the next important elements in a single line diagram for a feeder, which are current transformer and potential transformer. As we discussed earlier, current transformer is used to step down the current to 1 ampere or 5 ampere level, which is then used to feed the protection relay or measuring devices for the protection and measurement purpose of the feeder. Similarly, protection transformer is used to lowering down the voltage to 110 voltage level, and then it is used for the protection and measurement purposes. Now, the next important topic is where this current transformer should be located. So, as this is a series element and it needs to detect the current which is flowing through the feeder, we have the possibility to place it in two ways. Either it could be placed before the circuit breaker at this location, and it could also be placed as this location as we have shown right now. So let us consider if we are placing this current transformer before circuit breaker, for example here, then what happens? Suppose if we have a fault at the terminal of circuit breaker on this side, then what happens? The current that will be flowing through from this side will also flow through the current transformer, and it will be detected by the protection relay, and it will trip this circuit breaker. Once this circuit breaker is tripped, it will also give intertrip to the another circuit breaker at another end of the transmission line. So this will be not required in terms of tripping, as we do not have any fault on this part of the circuit. So in place of that, suppose if we are placing the circuit breaker as we have shown, and if we have a fault and at the terminal of the circuit breaker on this side, so any current which is flowing through this part, which will not be detected by this current transformer and the protection relay, and this circuit breaker will not be tripped. However, this current will be detected by the bus bar protection, and only this circuit breaker will be tripped. And we should be placing the current transformer after the circuit breaker as we have shown here. And the potential transformer is a shunt element, as we just need to detect the voltage. These are generally placed at bus bar also, and this can be used for the protection and measurement purposes. And this potential transformer sometimes can also be placed at the transmission line. Uh, there is also another variant of this voltage transformer, which is called CVT, capacitive voltage transformer, which is also used for power line carrier communication system. Regarding this topic, we will discuss in another video. Let's see some photos of current transformer and potential transformer. As you can see, this is the current transformer. As uh, we have CT as a series element, we can see both the terminal of current transformer are in series connection. You can see here. Let's see the photo of potential transformer. As I mentioned, it is a shunt element, and we can see only one connection is coming from line to the potential transformer, and another part of the potential transformer is connected to the ground. Now let's discuss about next and final element of the single line diagram, which is surge arrestor. As you can see here, surge arrestor is also a shunt element as it is connected between line and the ground. As we discussed earlier, surge arrestor is used to divert the surges from the line and divert it to the ground so that it can protect the circuit and other component of the feeder from the surges. Let's see some photos of a surge arrestor. As you can see here, this is a transmission line and there is a tap taken from this transmission line conductor to the surge arrestor and it acts as a shunt element. So with this, now we know the basics of single line diagram and how to prepare an SLD of a feeder. In next video, we will learn about different type of busbar schemes and how to prepare single line diagram of these schemes. Thanks for watching. If you learned something about single line diagram, then please like the video and do comment in case of any queries. Please subscribe Spectrum for more detailed and informative videos related to electrical engineering. See you in next one.